Now we are going to look at how to integrate products of sine and cosine. More specifically, by that I mean sine and cosine of constant multiples of the variable, namely integrals of that sort, for instance a product of sine and the cosine of constant multiples of the variable, or a product of two sines of constant multiples of the variable, or a product of two cosines of constant multiples of the variable. And it all comes down to these trigonometric identities that transform products into sums or difference. Specifically, if you take the product of the sine and the cosine, it's the 1/2 sum of the sine of the difference of the angles plus the sine of the sum of the angles. If you take a product of two sines, it's the half difference of cosine of the difference of the angle minus cosine of the sum of the angle. And if you take a product of two cosines, it's the half sum of the cosines of the difference and sum of the angles. So with that in mind, it is very easy to deal with the kind of integrals we just talked about, because, for instance, if I want to integrate sine of 3x multiplied by cosine x, then it's a product of a sine with a cosine, like here. So it's 1/2 of sine of the difference of the angle for the sine minus the angle for the cosine. So here alpha is 3x, beta is x. So alpha minus beta is 3x minus x 2x. And then alpha plus beta is 4x. So I get 1/2 of sine of 2x plus sine of 4x. Can pull out the 1/2 and then integrate just sine of 2x, whose entire derivative is negative 1/2 cosine 2x, and then sine of 4x, whose entire derivative is negative 1/4 cosine 4x. Multiplying things through, we just get negative 1/4 cosine 2x minus 1/8 cosine 4x, all up to a constant. To take a second example, let's consider the integral of sine of 5x multiplied by sine of 3x. So that corresponds to this formula giving a product of two sines as a difference of cosine. Namely, it is 1/2 of cosine of alpha minus beta minus cosine of alpha plus beta. Here you might say, okay, what is alpha, what is beta? Because we have two sines, so we could pick one or the other. And it changes something. If I take alpha is 5x and beta is 3x, and alpha minus beta is 2x. But if I pick it the other way around, alpha is 3x and beta is 5x, then when I take alpha minus beta, I get negative 2x. So how could it be? Well, it's not a problem, because when I plug this difference alpha minus beta inside the cosine, you know that the cosine of an angle or of its opposite is the same thing. So whether I get 2x or negative 2x, I obtain the same thing. So I can, for instance, take 5x minus 3x for the difference of the angles and 5x plus 3x for the sum of the angles, and I get 1/2 integral of cosine 2x minus cosine 8x. An antiderivative of cosine 2x is 1/2 sine 2x. Multiplying that by 1/2, I get 1/4 sine 2x. And then an antiderivative of cosine 8x is 1/8 of sine of 8x. Multiplying by 1/2, I get minus 1/16 sine of 8x. Let's look at one more example, the integral of cosine 2x multiplied by cosine 7x. Corresponding to the last formula, product of two cosines. Again, the same comment about what is alpha, what is beta. Well, it doesn't matter which one you pick, because when you take cosine of the difference, you get, depending on how you picked alpha and beta, you get either 5x or negative 5x, but that doesn't matter because cosine of an angle or of its opposite is the same thing. So we get 1/2 of cosine of the difference, which you can pick to be 5x, plus cosine of the sum, which is 9x. An antiderivative of cosine 5x is 1/5 sine of 5x, multiplied by 1/2 is going to give us 1/10 sine of 5x. And then an antiderivative of cosine 9x is going to be 1/9 of sine of 9x. When I multiply by 1/2, I get 1 over 18 sine of 9x. Now in the next video, we're going to look at integrals related to the secant function.